We must first understand the...
Okay, so back to Dalton's law, and Boyle's law. I have found some videos. I didn't realize they were there, and I'm going to tie this in, because now I actually have an understanding of it. So I'm going to leave the original post there because I think it's important to show the learning process as I've went through it, but to show the difference of being able to see it on this video and what I seen in the book when I didn't understand it, and now I get it. And I'm going to play the video.
air we breathe. The atmosphere is a mixture of gases, including oxygen, carbon dioxide, nitrogen, and water. Click the button to analyze the percentage of each gas in an air sample.
Alright, let's analyze the air.
The combined pressure of these gases equals atmospheric pressure. At sea level, atmospheric pressure is 760 millimeters of mercury, which means that the atmosphere pushes a column of mercury to a height of 760 millimeters. Each gas within the atmosphere is responsible for part of that pressure in proportion to its percentage in the atmosphere. Let's look more closely at gas pressure. Click the oxygen button to calculate its pressure. Watch the total pressure rise in the pressure gauge to the right.
Okay, so after watching the oxygen part, we can actually don't have to watch the rest of them because they're all going to do the same thing. It's a percentage of the total millimeters of mercury. So I'm going to do the oxygen and we'll go with air.
Oxygen comprises 20.9% of the atmosphere. The pressure exerted by oxygen is 20.9% of the total pressure of 760 millimeters of mercury, which equals 159 millimeters of mercury. This value is known as the partial pressure of oxygen and is written as P with a subscript O2. Click the gas buttons to calculate the remaining partial pressures.
So like I said, we're not going to watch all those. And one more to tie this in, so I can say that I've got both of them and can actually complete the objective with a learning basis of it. I did find this video as well. And let's watch this, what it has to say about Boyle's Law. If you can sense the extreme achievement in my voice, I don't like to be conquered, and I feel like I've just conquered this part of it because I found it.
In order to understand ventilation, we must first look at the relationship between pressure and volume. Pressure is caused by gas molecules striking the walls of a container. The pressure exerted by the gas molecules is related to the volume of the container. Click the sphere to see how volume affects pressure. This large sphere contains the same number of gas molecules as the original sphere.
So
notice that in this larger volume, the gas molecules strike the wall less frequently, thus exerting less pressure.
They're not moving any slower, though. That's the key.
Click the sphere to see what happens when it is decreased in size.
So this is the relationship between pressure and volume. The smaller the volume with the same particles of gas, the higher the pressure is going to be. You have more volume, less pressure. It makes sense. It makes sense when I see it this way. Do you not? I mean, you should really people should take advantage of every technological device that's given to them to learn.
In this small sphere, the gas molecules strike the wall more frequently,
higher pressure,
thus exerting more pressure. Notice that the number of gas molecules has not changed. These demonstrations illustrate Boyle's law, which states that the pressure of a gas is inversely proportional to the volume of its container. Thus, if you increase the volume of a container, the pressure will decrease. And if you decrease the volume of a container, the pressure will increase.
Okay, that's the exact same thing.
Click the buttons to change the size of the sphere and see the demonstrations again.
That's the exact same thing the book said, and I did not get it. I did not understand it until I seen it. So, I hope that in making this blog, that maybe I can actually share it with somebody and they'll be able to understand something too. Because I put a lot of time into these, and it's straight from our book. So this is all the information that is in our books, but in an animated form.